ready for me to start?
Yeah, go ahead, John.
All right. Well, thank you for inviting me to attend your meeting. I appreciate it, and it's an interesting topic. I didn't put together a very detailed presentation because I wanted it really to be more interactive. Let me just give you a little bit of my background. I'm not an engineer. I am not an operator of commercial solid state amplifiers, and I'm not a contester. What I am is an experimenter, and I've been building and using solid state amplifiers for, probably 12 or 13 years. And I'm sorry to hear about all the problems that you've had because I have not experienced that. So I want to pick up some of the information from you as well as give you my perspective. I followed all of the reflectors, at least all the ones I can find, every day. And I track the developments within this industry. And I had a really interesting conversation with the designer of M-Squared's VHF and UHF amplifiers at Dayton about 4 years ago. And what he told me was they considered producing an HF LD-MOS amplifier and could never get it to work well, so they dropped the project. Now, I don't know how accurate that is, but at the time I had the same concerns. The gain of these things is scary, it's so high. And the heat concentration in such a small area is intense. And the ability for it to go into oscillation because of this extremely high gain, it was a challenge to hold the thing back. So I'm just going to tell you a little bit about what I'm doing right now. I'll point out some of the failures, and I'll try to address some of the questions that I got from Mike. So first of all, LD-MOS is now the dominant MOSFET in all amplifiers. But there's nothing wrong with the old quote-unquote VD-MOS amplifiers. This would be like the ICOM PW1, the Yaesu Quattro, Tokyo High Power, Meritron ALS 1300 or 1306. What drove the migration wasn't the fact that the LD-MOS was a better technology. It's just that the VD-MOS was being obsoleted by other non-ham users of MOSFETs to go to LD-MOS. You know, things like pulse generators, plasma generators, and MRIs, and especially cell tower base stations. This technology was never designed as a single sideband HF device. So even though I have a full legal limit water-cooled LD-MOS amplifier, my primary amp is still a 1 kW VD-MOS. It's very, very, very similar to the Tokyo High Power. It's been in use for about 10 years, and I'm happy to report not a single failure. And I've transmitted into disconnected antenna lines. I've transmitted into the wrong low-pass filters. And luckily enough, my protection circuits have always kept me safe. So, you know, why did we do this transition? And, you know, if there's problems, why can't we fix them? First of all, if you read the marketing hype, and it started out with the BLF 188XR, which was alleged to be, you know, indestructible and withstand a 65 to 1 SWR with no damage. Yeah, but that's in pulsed operation at a single frequency. It's not broadband. It's not the type of conversational use that we do. The LD-MOS was originally designed for UHF. It was designed for, you know, use in cell tower base stations. And when you bring that down to the HF range, it has an insane amount of gain, about 29 dB. It's really, really hard to harness that. It's also a very small device, which is nice when you're trying to package it into a small cabinet. but it also concentrates heat into a very, very small physical area, making it hard to dissipate that heat. But it does provide lower cost per watt dramatically. And most, if not all, the new commercial amps are now using the LDMOS technologies. So why did they do it? Why did Elecraft and Flex and Expert change? The Elecraft KPA 500 is a VDMOS device, extremely reliable. The let's see, which one would it be? Expert. The SBE 2000 is a VDMOS device. If you look at my amplifier, it has 4 SD2933s needed for a kilowatt in each pallet for a cost of $480. To get to a full legal limit, you'd have to have 2 of those pallets. That's 8 MOSFETs, $960, plus a splitter and combiner for about $170. So just for the transistors and the combiner, you're looking at $1,130. Compare that to an MRFX 1K80H, $282. And it's a much smaller PA module, which allows the manufacturers to have the smaller cabinet that people want so they can put it on their desktops. The days of having the Henry amplifiers are kind of over. They're not indestructible. I hate to bring you the bad news. No transistor is. Early in my amplifier project, I blew 2 of them up and I did nothing wrong at all. I just was increasing the drive until I hit 500 watts, and at about 550 watts, I had a big arc and blew 2 MOSFETs up. Nearest I could tell, there was nothing wrong with my operation or my circuit. It was the transistors themselves. And these were probably Chinese knockoffs. And I bought originals from DigiKey, and I've never had a problem since. The Achilles heel in a LDMOS transistor is the gate voltage. In the past, with bipolar transistors, you could abuse the input, you could overdrive them, you know, it would cause splattering, and you'd have some ill effects, but it wouldn't blow up. VDMOS, same thing. I could, overdrive it. I had a Kenwood TS480 that had a horrible time with overdriving spikes. You could set the output power at, let's say 10 watts. And when you keyed it up, you'd probably hit 100, it was a 200 watt radio. You'd probably hit close to 200 watts for, some number of milliseconds. Well, the LDMOS transistors will not survive any spike, not for any length of time. So a lot of the radios that we're using for exciters have an overshoot. It's very common in many radios. So the amplifier vendors have tried to minimize that by putting attenuators with inside the amplifiers. But they do that also to meet the FCC requirement, which is no more than 15 dB a gain. And remember what I said, with you have up to 29 dB of gain from the transistors. So you're dumping a lot of power into an attenuator as heat. I avoid that by using all QRP radios. So all my exciters are 10 watt radios, Elecraft K310, a KX3, and a Hermes Light SDR. So I can run my exciters at full power and not damage my transistors. But even with those, I have to put an attenuator in because it only takes about 2 watts of drive to push one of these LDMOS amplifiers to full legal limit. So let's look at that again, 2 watts. So if you get a spike that lasts a couple of microseconds and it's 100 watts, it's going to cost you some money. So there's been lots of discussion about how do you reduce the power of your amplifier, of your exciter. You can't just turn it down. If you turn it down on a lot of radios, it really doesn't do anything. Not for those first couple of milliseconds. There's been discussion on using external ALC, which this is not the same as ALC from the amplifier to the exciter. This is a external negative ALC voltage to the transceiver. MFJ has a device called the TPC 150, but you can also home brew one real easy with a 9-volt battery and a potentiometer. The idea is that you lower the voltage of the transceiver with this external ALC instead of relying on the power control within the radio. The other thing you can do is, run full power, run your 100-watt radio, but use an adjustable external attenuator. Remote QTH, which is a website in Europe, has such a device. And you can make it so that you can't make a mistake. The other thing that can cause this spike in input power is high SWR. So you say, well, how does high SWR affect the negative or the voltage to the gate? A lot of amplifiers, especially the first generations of these LDMOS amps, use negative feedback from the drains to the gate to get a control on the excessive gain of the device. The problem with that is if you get a momentarily bad SWR, it can reflect a high voltage spike back into the gate. And again, there goes your MOSFET. The other leading killer, and this is one you can control, is heat. When the first generation LDMOS devices came out, and I'll pick on SBE Expert because they were probably one of the first ones to come out, they bolted the transistors down with heat transfer grease to a copper heat spreader. And that's what we used to do with the VDMOS devices. But what we're finding over time is that's just not adequate. Over time, the heat transfer grease breaks down. Because of the excessive heat, the MOSFET package itself gets distorted. And pretty soon you get air between the transistor and the heat spreader. Well, air doesn't conduct heat very well. So the alternatives are soldering and or clamping. Elecraft, for example, started out with just bolting the package down, and they're now soldering all theirs down. Some of the other companies are going to a clamp that goes over the top of the transistor. And then instead of using thermal grease, they're using iridium pads. Well, if you got an amp that's a couple of years old, you probably aren't benefiting from some of the experience that some of these vendors have had. In my amps, I solder them down. I also use water cooling because I don't believe that the temperatures that the vendors are allowing is safe over time. If you look at the NXP data sheet for the MRFX 1K80H, the maximum case temperature is 150 degrees centigrade. Well, to get to where you could measure it within an amplifier, it's got to go through the case and get into the heat spreader, and it gets distributed through the heat spreader. So depending on where the vendor places their sensor really determines, how accurate the temperature reading is that you're getting. But even if you're below that 150 C, over time, the thermal grease can break down or the MOSFET itself can distort. So here's some interesting statistics. These are maximum temperatures that are allowed or recommended in some cases by a variety of suppliers. W6PQL is probably one of the most respected homebrew kit suppliers. And he's been building LDMOS amps for many, many years for VHF and UHF. His cutoff high frequency where it goes into standby is 54 degrees centigrade. My amplifier, my LDMOS amp, I have mine, I think, at 55 degrees C. The Mercury, which is another, I'll call it a homebrew amplifier in a kit form, very conservative, very, very, very good reviews, not seen any discussion on failures. Their maximum temperature is 65 degrees. Some of the older amps, the Tokyo High Power, which is basically what I have home brewed, it's 70. And you can read the rest of the list as it goes up. But as you get into some of them, this temperature starts to get excessive. The ACOM is up to 80 C. And Elecraft, the KPA 1500, according to their manual, you can go to 110 degrees C. Does anybody have any experience with the Elecraft KPA 1500 and what its maximum temperature is? Am I talking into a dead mic?
No, you're good. Everything's good.
Okay, all right. The other, so watching temperature, and I'll talk about this more, I think is critical, especially over time. It may not kill it immediately, but because it's damaging the thermal interface between the transistor and the heat distribution, the heat spreader, you develop air gaps in there. And then all of a sudden it can spike the junction temperature of the transistor, and you didn't do anything wrong, but you just lost your MOSFET. All right, another controversy that was raised in the email was, should we ALC or not? Well, for a lot of us, we don't have any choice. Most new radios, especially the SDRs, don't have an ALC input to control transmit power. And most of them, if you could, wouldn't recommend doing it. Many of the amp vendors are also not recommending using ALC to control input power. And why is that? Remember, this is not the same as I talked about before, the external ALC voltage being supplied. This is the ALC loop. The response is way too slow. By the time the transceiver gets the ALC information and to decrease input power, you've already blown your amplifier up. So none of my radios have ALC, so obviously I don't use it. I'm not a vendor, I can't speak for them. I can only say that probably the main reason that they tell you that you have to use it is that when you blow up your transistors and you didn't use it, they can say, see, I told you so. The other question was on protection circuits, and all my amplifiers have a combination of analog and digital protection circuits, and they do a lot of neat things like monitoring power and SWR and temperature. And most vendors are using microcontrollers to do that and hopefully shut the amp down before there's damage. Accidental high SWR usually isn't a problem. If you've got the wrong antenna connected, or you've got the wrong low pass filter connected and your SWR goes high momentarily, the protection circuits will shut it down before the transistor overheats. But that's nice. They can't react fast enough to prevent overdrive to the MOSFET gate from destroying the MOSFET. I don't believe any circuit that's microprocessor controlled can do that. Many of the amplifiers, Elecraft for one does it. So does RF kits. They put transient spike protectors in, which are back-to-back Zeners to supposedly clamp the input voltage below a critical level, but they're still experiencing failures. So I had them in my amp and I took them off. I figured it really wasn't doing me any good, especially because I have QRP radios. So if you read all the reflectors, there's just a lot of discussion about, what's going on? Why can't the vendors fix this? And, I have a lot of friends that have the same amplifiers that you guys talked about, and they've had them for years and they've had no problems. And I've talked to other hams that have had multiple failures of the same amplifier. There's been discussion maybe that there's a high failure rate from the manufacturers like NXP on the MOSFETs. There's also a lot of discussion, it's the way that we use a transistor. puts a lot more strain on it than continuous commercial operation. We're doing, let's use FT8 for an example. We're transmitting for some number of seconds and then pausing for another amount of time, and then back on and back off. That heating and cooling is potentially breaking down the heat transfer interface. So what can we do to prevent failures? And here's where I'm going to get pushback from people, and people are going to say, "Oh, I bought this thing so I could run full duty cycle, and my vendor says I can run 100% full duty cycle." Okay, have fun. Watch your operating temperature. Don't rely on the protection circuit, and be conservative. How conservative that, I can't tell you. I don't have any experience with your amplifier. All I can say is I run FT8 a lot, and I'm a DXer. I'm not a contester. And I run FT8 at about 800 watts out of my kilowatt amplifier. And if I'm after, a country that I can't get any other way, I'll tweak it up a little higher to a kilowatt, but I watch the temperature gauge. And when it gets up to 110, 115 degrees Fahrenheit, I back it down. I would never operate ever at 60 degrees C. You have to really be conservative when you're running FT8 on 6 meters. And a lot of the people that I've talked to that have had amp failures, this has been the mode of operation that has been the cause of the failure. These transistors, the gain drops off as the frequency increases. And so they've built a lot of circuitry in to get higher power on HF, or to limit the power on HF. And so they aren't as efficient on 6 meters. Also, the broadband nature of the output transformer is such that it's really difficult to get broadband high efficiency. You look at a 1.5 kW amplifier, to operate efficiently, you have to have a 16:1 ratio on your output transformer. The higher that ratio gets, the lower or smaller the bandwidth becomes for broadband efficiency. So like on my amp, I can get 2,800 watts out on 160 through 10 meters. And that's honest into an accurate watt meter and into a bird dummy load. On 6 meters, I get about 800 watts. But what's interesting is that the heat going into the heat spreader is higher at 800 watts on 6 meters than it is at a full legal limit, 1.5 kW on, let's say, 80 meters, because you don't have the efficiency, so more of the energy is going into heat. You also have to increase the drive to get full output on 6 meters. So your gate voltage becomes higher and closer to that failure point. So you're more susceptible to failures. And then my last comment is always use an auto tuner and don't operate if your SWR is high. My goal is always have the SWR below 1.5, and most of the time it's 1.2 or 1.1 to 1. That gives you a little bit more headroom. And same thing with not running it at full power. I know that, and we'll open up the mics in a minute, we can have some discussions, but there's another presentation coming on next week by the Madison DX Club. And they've got a renowned author, Adam Farson, VA70J, who has authored many reviews of radios and amplifiers. And his program is going to be selecting a solid state amplifier for DXing and contesting. So I'd really like to listen in on that presentation to get his perspective on it. So I'd like to just open up the floor and let's entertain some questions and just kind of have a round table discussion. do we have people on the call that have had an amplifier failure?
Oh, yeah.
Okay.
Well, you asked about the
I can't hear you. You're muted.
that I've
There.
seen on a KPA 1500, and I haven't really seen it go over 70, but I don't know where the sensor is, so you know it's kind of.
Well, that's what I found interesting, because I look at the reflector and they talk about 70 as what most people are stopping it at, but the specs, you know, take it higher than that.
Okay, well.
What do you see in normal operation? You know, non-contesting, if you're chasing DX, what do you see your temperature get up to?
Well, if I'm really pounding 70, but no higher than that, but most of the time, mid 50s.
And have you had a failure?
Yeah, I've lost some devices and sent it back. Not much of an explanation. I replaced the devices. My other question is why don't we see some of the amp manufacturers go to water cooling? Is it that difficult?
You know, that's a good question. All the commercial amplifiers, if you go to a radio station, TV station, they're all water cooled. I mean, it's just something unusual. I mean, I can put full key down on FT8 or RIDI, and I could do it for hours and I wouldn't hit 55 degrees C. And it's not that tough to do. You know, you've got a heat transfer plate underneath the heat spreader. You've got a water pump, you know, you've got a radiator, you've got fans blowing on the radiator. It makes it bulkier. You know, it's not something that's going to sit on your desktop, but it's definitely a way to keep the amplifier running cool. You're muted again.
I wouldn't see a problem in most applications where having the cooling reservoir or whatever and the pump remote, like a couple of feet to 5 feet away, would be a big problem.
Yeah, and it's actually quieter than the fans on a KPA 1500.
For sure.
So I think over time, you're going to see a movement in that direction. I mean, I'm sure these vendors have to be frustrated. And I've watched every one of them. And the only one that I haven't seen any reference to MOSFET failure has been Mercury. I've seen it from every other one. And the only correlation I make is Mercury's limiting the temperature. And the other thing that's different with Mercury is that it's a single MOSFET, just like the SPE, but it's limited in its power to like a kilowatt or 1200 watts. So they're not running it to full legal limit, which means they don't need a 19:1 ratio output transformer. So again, it's a little safer operating. Same with the W6PQL. It's a 1200 watt amplifier.
Yeah, I've only seen one water cooled stuff.
I didn't understand that at all. Could you get closer to the mic, please?
The only water cooled amp I've seen available was from a Russian vendor.
Yeah, before the invasion of Ukraine, I bought a lot of stuff from Victor. Matter of fact, my amplifier uses a diplexer from Victor, but if you've looked at any of his reflector feedback, his radiator system was undersized on that water-cooled amplifier, and it's not effective.
Well, that was internal, right? He didn't do it.
How about anybody else? Any other amplifier failures, other vendors, modes of operation? Am I on the track when talking about, digital modes and running them too hard?
You guys on Zoom? Anybody got something? You guys all fall asleep?
Oh, no, we're here and listening carefully. Thank you, Don.
Mike, I have just a minor observation. I've blown my expert up twice, and one time on 6 meters. Can you hear me okay?
Yes, really good.
And yeah, the other time, and I've never run the temperature more than 60. Usually when it gets up in the mid to upper 50s, I back off. But it's nonetheless, it's blown up twice. That's hooked up to a Flex 6600. But what interesting comment about, it may sound kind of dumb, but about water cooling. I spent the day doing an installation in an industrial environment and next to a bathroom where the sink was leaking. So I'm standing in a puddle of water most of the day. And I'm telling you, my feet were freezing because a water interface between your shoe, and my shoes don't leak. My feet weren't wet, but the fact that the floor was wet, it sucked the heat right out of my toes. So water cooling is very effective.
Well, with your Flex, you definitely do not have any over spiking issue.
Okay.
The only thing that I could say is that how much drive power did you have to have on 6 meters to get the power output you wanted?
Well, that's interesting, Don. I always thought that, I was told with the expert, never run more than like 10 watts. Well, then I talked to Bob at Expert, and he asked me all the conditions. He was very thorough and asked what were the operating conditions. And I revealed that to him. I said, well, I was told never to run more than like 10 or 15 watts. And he said, that's the problem. If you're there's 3 different power levels, low, medium, and high. And maybe in the low setting, and the second time it failed, it actually said, I think it said something, there was an alert that came up that said amplifier inefficiency. And that was on FT8. And I was running, I think maybe max with not much drive. And then the next time the FT8 keyed down, it blew the trip. So he said, you want to run the high mode at like 30 watts. I was always afraid to run the drive that high because it would trip out. But his rule of thumb is 30 watts in high, 20 watts in low, and maybe 10 to 15. And I'm sorry, 20 watts in medium and maybe 10 watts in low. So I wasn't aware of that, requirement. But and so since I've been operating it with that in mind, although in my home station, I've changed philosophy, and I went out and bought an OM 2000 Plus, which has a tube. So I haven't had the expert on mine because I'm afraid to blow it up again. So
I'm sorry to hear that. What model expert do you have?
It's a 1.3 KFA.
Okay, yeah, a good friend of mine has had a 1.3 for years and years and years and years, and he's never had any failure at all.
And so have others in the group here that have them, and they're just fine. So I don't know, and my SWR is always good. I always, make sure the antenna is. I have a stepper vertical, so I tune the antenna first, and so I don't know, but.
It's just interesting because if I had to put together a spreadsheet and track failures, the number one failure is 6 meter FT8 operation.
Well, that was the first failure, was 6 meter FT8. Yeah, the other one was like 20 meters FT8. So,
but you may have inadvertently damaged the thermal interface over time. I don't agree with everything SBE does. I mean, SBE is a great amplifier. I'd consider owning one, but their recommendation to use ALC, I don't agree with. They bolt their devices down to the heat spreader, not even clamped. And they use a 9-to-1 output transformer, which is a bad mismatch at full legal limit. So it's amazing they get as good a performance as they do out of it.
Well, actually, my 6-meter failure was the first one. And I think you might have mentioned it because I watched your presentation before, and I was probably running a kilowatt out of it. Well, then I was told, on 6 meters, you don't want to ever do that. Maybe don't go over 500 watts. So with the expert 1.3. But anyway, anybody want to buy a 1.3? Because I switched I see Mike clapping his hands there. I'm going to stick with a tube amp for my home station. So.
What's interesting is that when I designed my amplifier, I based it off of what Tokyo High Power was doing, and it's got a very similar design. But Tokyo High Power, for marketing purposes, really felt they had to get 6-meter operation out of their 1.5 amplifier. And to do that, they had to lower the value of a gate resistor from about 3 ohms to a 0.5 ohm, because the gate resistor and the internal capacitance of the MOSFET was functioning as a low pass filter, and it was cutting off the 6-meter drive. And I was friends with the engineer from Microsemi who helped them design that amplifier, and actually went out to Tokyo to try and figure out why they were blowing so many of their amplifiers up. And it was that gate resistor value to allow them to get 6-meter operation. They ended up putting in a little bit more rugged device, but yeah, that was their failure point. When you're trying to get a broadband amplifier to go from 160 to 6 meters, it's a challenge. If you're really dead serious about wanting to do 6-meter FT8 or 6-meter moon bounce or whatever, a good friend of mine does it. He does moon bounce with 1.5 kW, and he runs a Henry amplifier for that.
I haven't had the OM power on 6 meters yet. I have to put my 3 element Yagi up temporary, but we'll see how it works this season. So I think the OM uses a Chinese tube. So
I think you're a little bit safer. Yeah, that's for sure.
So,
I hope
but
that
I appreciate all your info. Thank you.
I hope the industry can do something to mitigate this problem. And I don't think any vendor is immune from it. And I think they're all pulling their hair out going, what the heck happened here? Because, they might have 1,000 amplifiers out, and their failure rate is actually pretty small. But doesn't help you when you're one of the small ones that had a failure and you didn't do anything wrong, All right, well, thank you very much, guys. Anything else?
Just 2 comments, Don. Number 1, the 6-meter bug certainly is recognized. That was what was the final delay on the Flex Power Genius. They were ready to ship and then got some 6-meter feedback, and that took them another 6 months or so to clean up. And your comment regarding relatively low failure rates, probably spot on, but as one of our friends would say, those are guys that turn the amp on, run single sideband, make 6 contacts, or CW 6 contacts a day and turn it off. They're not the guys that are running FT8 and are running the amp, at least in the operate position, a valid 4 to 6 hours a day, which is a lot in terms of temp.
Oh, it definitely is, and it's a long-term effect is what they're seeing. It's causing damage over a period of time. I used FT8 when I wanted to get 40-meter DXCC, and I pushed it pretty hard. I did the same thing for 80 meters. So I mean, I was running at least a couple of hours a day, at pretty close to full power. But like on my amplifier, my VDMOS amplifier, I hand lapped all of the transistors until they were so shiny you could see your face in them. I had the copper heat spreader, milled to as flat as they could get it. And I was really, really careful with a small amount of thermal heat grease, and I used a very expensive thermal heat grease. So I got to believe I've got pretty good transfer of heat. And then I watch it like you guys talked about. If it ever got up to even 55C, I'd be shutting it down. Now the LD MOS devices, they're running them hotter, and I think they have to just because of the size and the inability to get rid of heat. So I started this conversation out by saying I'm not a contester. I'm an avid DXer, but I'm primarily CW and single sideband. And you know how it is when you're going after somebody on CW at 35 words a minute, you're not transmitting for a very long period of time. TU 73, K9AQ, done, gone. That's why I think this presentation that Madison Club is putting on would be more educational on how to select the right amp for it. I mean, if I was going to get an amp today, the two that I would look at would be the Flex Power Genius and the Elecraft KPA 1500. In my opinion, I thought those were really, really, really solid amplifiers. So to hear that you're having failures with some of those is disconcerting.
Very good.
Mike,
Thank
do you
you.
have the link to that Zoom meeting from the Madison DX Club?
Yeah, it was in Bernie's bulletin, I think today.
Yeah.
So,
Hopefully I'll see some of you there.
there you go.
All right. 73s, everybody.
Thanks.
Thank you.